This is the EdExcel AS Level Maths Paper 1 from the 2024 series. Question number 1. Find the integral of 2 multiplied by root x subtract 3 over x squared with respect to x, giving an answer in simplest form. Let us write this result in an integrable form. We have the integral of 2x to the 1/2, which is the same as 2 multiplied by root x, subtract 3 over x squared, and we wish to integrate this with respect to x. And what this is equivalent to is the integral of, well, 2x to the 1/2 divided by x squared, that's 2x to the negative 3 over 2, and negative 3 over x squared is the same as negative 3x to the negative 2. So we integrate 2x to the negative 3 over 2 subtract 3x to the negative 2 with respect to x. If we integrate 2x to the negative 3 over 2, we end up with negative 4x to the negative 1/2, and if we integrate negative 3x to the negative 2, we end up with positive 3x to the negative 1, and then we add on a constant of integration c, and therefore the integral of 2 multiplied by root x subtract 3 over x squared with respect to x is equal to negative 4x to the negative 1/2 plus 3x to the negative 1 plus c. Question 2. F of x equals 2x cubed subtract 3ax squared plus bx plus 8a, where a and b are constants. Given that x subtract 4 is a factor of f of x, part A, use the factor theorem to show that 10a equals 32 plus b. If we know that x subtract 4 is a factor of f of x, that means if we set x subtract 4 equal to 0, we can see that x equals 4. Now, if x subtract 4 is a factor of f of x, then f of 4 will equal 0. And now, substituting 4 into f of x, we find f of 4 is equal to 2 multiplied by 4 cubed subtract 3a multiplied by 4 squared plus b multiplied by 4 plus 8a. This is all equal to 0. Therefore, we have 128, and we have minus 3a multiplied by 16 plus 8a, that's negative 40a, and we add on to this 4b, this is equal to 0. And if we rearrange and simplify, we can conclude 10a equals 32 plus b. Given also that x subtract 2 is a factor of f of x, for part B, we have to express f of x in the form f of x equals 2x plus k multiplied by x subtract 4 multiplied by x subtract 2, where k is a constant to be found. For part B, if we know that x subtract 2 is a factor of f of x, that means if we set x subtract 2 equal to 0, we can see x equals 2, and if x subtract 2 is a factor of f of x, then f of 2 is equal to 0. And now, substituting 2 into f of x, we find f of 2 is equal to 2 multiplied by 2 cubed subtract 3a multiplied by 2 squared plus b multiplied by 2 plus 8a, and this will all equal 0. So we have 16 subtract 12a plus 2b plus 8a equals 0, and if we simplify this, we have 8 plus b equals 2a. To find a and b, we need to solve this equation with this equation simultaneously. If we go to the equation submenu using our calculator, we have a simultaneous equation with two unknowns. So we have 10a subtract 1b equals 32, and we have 2a subtract b equals 8. And if we solve this, you will find a to equal 3 and b to equal -2. Knowing what a and b are, we can now state what f of x is. So f of x is equal to 2x cubed subtract 3 multiplied by 3 multiplied by x squared subtract 2x plus 8 multiplied by 3. And if we simplify this, f of x is equal to 2x cubed subtract 9x squared subtract 2x plus 24. We also know f of x can be expressed in this form here. So f of x is also equal to 2x plus k multiplied by x subtract 4 multiplied by x subtract 2. And to find out what k is, we can compare the number terms. Of course, comparing the number terms, we would have k multiplied by -4 multiplied by -2 equals 24, which means k is equal to 3. And knowing that k equals 3, we can therefore conclude f of x equals 2x plus 3 multiplied by x subtract 4 multiplied by x subtract 2. Part C. Hence, for the first part, state the number of real roots of the equation f of x equals 0. From part B, we already know what f of x is. That's equal to 2x plus 3 multiplied by x subtract 4 multiplied by x subtract 2. Now, if we wish to find the solutions of f of x equals 0, we need to set each of these brackets equal to 0 and then solve. So, f of x equals 0 has solutions. Well, if I set 2x plus 3 equal to 0, x will equal -3/2. If I set x subtract 2 equal to 0, x will equal 2. And if I set x subtract 4 equal to 0, x will equal 4. So f of x equals 0 has solutions x equals -3/2, 2 and 4. And what you can therefore see is we have 3 real solutions. For the second part of part C, write down the largest root of the equation f of 1/3 x equals 0. If we think about f of x over 3 equaling 0, well, we know the solutions of f of x equals 0 from the first part of part C. And going from f of x to f of x over 3, we have a stretch by scale factor 3 in the x direction, which means to find the solutions of f of x over 3 equals 0, we would have to multiply each of these solutions by 3. So f of x over 3 equals 0 has solutions x equals 3 multiplied by negative 3 over 2, 3 multiplied by 2, and 3 multiplied by 4. So we have negative 9 over 2, 6, and 12, and therefore this 12 is the largest root of f of x over 3 equals 0. Question 3. Relative to a fixed origin O, point P has position vector 9i subtract 8j, point Q has position vector 3i subtract 5j. Part A, find the vector PQ. The vector PQ is equal to the vector OQ subtract OP. So we have the vector OQ, which is 3i subtract 5j, and we subtract from this the vector OP, which is 9i subtract 8j. So 3i subtract 9i, that's negative 6i, negative 5j subtract negative 8j, that's positive 3j. So the vector PQ is equal to negative 6i plus 3j. Given that R is the point such that QR is equal to 9i plus 18j, part B, show that angle PQR is equal to 90 degrees. For part B, we know that QR is equal to 9i plus 18j, and to show that PQR is 90 degrees, we need to show that the dot product PQ dot with QR is equal to 0. So we have PQ, which is negative 6i plus 3j, dot with QR, which is 9i plus 18j. And if I end up with 0, we can conclude that PQR is 90 degrees. So we have negative 6 multiplied by 9 plus 3 multiplied by 18, which is 0. And because PQ dot with QR is equal to 0, we can conclude PQR is 90 degrees. Given also that S is the point such that PS is equal to 3QR, for part C we have to find the exact area of PQRS. For part C, we can find the magnitude of PQ. That's equal to negative 6 squared plus 3 squared square rooted. And working this out, we have 36 plus 9 square rooted, which is 3 root 5. We can find the magnitude of QR. That's equal to the square root of 9 squared plus 18 squared. Working this out, 9 squared plus 18 squared is 9 root 5. We also know that the magnitude of PS is equal to 3 multiplied by the magnitude of QR. That is because PS equals 3QR. So we have 3 multiplied by 9 root 5, which is 27 root 5. Here we have the trapezium PQRS. Notice PQR is 90 degrees. We have PS, which is 27 root 5, PQ, which is 3 root 5, QR, which is 9 root 5. So to find the area of this trapezium, we have 1/2 multiplied by 9 root 5 plus 27 root 5 multiplied by 3 root 5. So we have 36 root 5 multiplied by 3 root 5 divided by 2, which is 270. So the area is 270 units squared. Question number 4. Figure 1 shows a sketch of triangle ABD and triangle BCD. Given that ADC is a straight line, BD equals x plus 3 centimeters, BC equals x centimeters, the angle BDC is equal to 30 degrees, and the angle BCD is equal to 140 degrees. And by the way, if ADC is a straight line, the angle ADB is equal to 180 degrees, subtract the 30 degrees, which is 150 degrees. Part A, show that x equals 10.5, correct to 3 significant figures. If we consider the triangle BCD, we have the length BC and the angle opposite it, BDC, which is 30 degrees. We have the length BD, which is x plus 3 centimeters, and the angle opposite it, BCD, which is 140 degrees. We can set up an equation using the sine rule. We have x over the sine of 30 degrees, which is equal to x plus 3 over the sine of 140 degrees. And if we cross multiply, we have x multiplied by the sine of 140 degrees equals x plus 3 multiplied by the sine of 30 degrees. And if we expand and then gather everything that contains an x on one side and anything that doesn't contain an x on the other side, we have x multiplied by the sine of 140 degrees, subtract x multiplied by the sine of 30 degrees, and this is equal to 3 multiplied by the sine of 30 degrees. On the left hand side, if I factorise out an x, we have x multiplied by the sine of 140 degrees, subtract the sine of 30 degrees. This is equal to 3 multiplied by the sine of 30 degrees. And therefore, x is equal to 3 multiplied by the sine of 30 degrees divided by the sine of 140 degrees, subtract the sine of 30 degrees. So let's work this out. We have 3 multiplied by the sine of 30 degrees divided by the sine of 140 degrees, subtract the sine of 30 degrees. It turns out we get 10.505 etc., which to 3 significant figures is 10.5. Given also that AD is equal to x subtract 2 centimeters, part B, find the length of AB giving an answer to 3 significant figures. If we consider the triangle ABD, we have AD, which is x subtract 2 centimeters, BD, which is x plus 3 centimeters, and the angle ADB, which is 150 degrees. We can find AB using the cosine rule. So for part B, AB squared is equal to x subtract 2 squared, which corresponds to AD squared, plus x plus 3 squared, which corresponds to BD squared, subtract 2 multiplied by x subtract 2, which corresponds to AD, multiplied by x plus 3, which corresponds to BD, multiplied by the cosine of 150 degrees. We know what x is, that's 10.505, etc. So we have 10.505, etc. subtract 2 squared plus 10.505, etc. plus 3 squared subtract 2 multiplied by 10.505, etc. subtract 2 multiplied by 10.505, etc. plus 3 multiplied by the cosine of 150 degrees. So let's substitute all of this into our calculator. We have the 10.505, etc. subtract 2 squared plus the 10.505, etc. plus 3 squared subtract 2 multiplied by 10.505, etc. subtract 2 multiplied by 10.505 plus 3 multiplied by the cosine of 150 degrees. And if we work this out, AB squared is equal to 453.67, etc. And to find out what AB is, we square root the 453.67, etc. and we end up with, to three significant figures, 21.3. Question number 5. The curve C1 has equation y equals 6 over x plus 3. For part A, for the first part, sketch C1 stating the coordinates of any points where the curve cuts the coordinate axis, and then for the second part, state the equations of any asymptotes to the curve C1. For part A, we have the curve C1, which is y equals 6 over x plus 3. We have a horizontal asymptote, y equals 3, and a vertical asymptote, x equals 0. The curve C2 has equation y equals 3x squared subtract 4x subtract 10. Part B, show that C1 and C2 intersect when 3x cubed subtract 4x squared subtract 13x subtract 6 equals 0. We have the curve C1, 6 over x plus 3, and we set this equal to the curve C2, which is 3x squared subtract 4x subtract 10. And if I multiply both sides by x and simplify, you will find we end up with 3x cubed subtract 4x squared subtract 13x, and that comes from negative 10 multiplied by x subtract 3 multiplied by x, and then we have negative 6, and we set this equal to 0. Given that the x-coordinate of one of the points of intersection is negative 2/3, part C, use algebra to find the x-coordinates of the other points of intersection between C1 and C2. Well, if we solve 3x cubed subtract 4x squared subtract 13x subtract 6 equals 0, we end up with a solution x equals negative 2/3. And if we work backwards from this, we can state then that 3x plus 2 is a factor of 3x cubed subtract 4x squared subtract 13x subtract 6, which would mean 3x plus 2 multiplied by a quadratic factor is equivalent to 3x cubed subtract 4x squared subtract 13x subtract 6, and we are required to find this quadratic factor, and we can do this using inspection. 3x multiplied by x squared gives us 3x cubed, 2 multiplied by negative 3 gives us negative 6, and to find the x term, well, we want to end up with negative 4x squared. We have so far 2x squared, and 2x squared subtract 6x squared would give us the negative 4x squared. So to get this negative 6x squared, 3x multiplied by negative 2x would give us negative 6x squared. So we have 3x multiplied by negative 2x, which is negative 6x squared, and adding on to that 2x squared would give us negative 4x squared. Now we can factorise the quadratic x squared subtract 2x subtract 3. So we have 3x plus 2 as it remains, multiplied by x subtract 1 multiplied by x plus 3, which is the same as x squared subtract 2x subtract 3, and this is equivalent to 3x cubed subtract 4x squared subtract 13x subtract 6. And to solve this cubic equal to 0, we would have to set the product of these three linear brackets equal to 0. So we have 3x plus 2 multiplied by x subtract 1 multiplied by x plus 3 equals 0, from which we can see x is equal to negative 2/3, x is equal to 1, and x is equal to negative 3. Question number 6. The binomial expansion of 1 plus ax to the power of 12 up to and including the term in x squared is 1, subtract 15 over 2x plus k x squared, where a and k are constants. For part A, to find the expansion of 1 plus ax to the power of 12, we have 12 choose 0 multiplied by 1 to the 12 multiplied by ax to the power of 0 plus 12 choose 1 multiplied by 1 to the 11 multiplied by ax to the power of 1 plus 12 choose 2 multiplied by 1 to the 10 multiplied by ax squared, and then we add on the higher order terms. So 12 choose 0 multiplied by 1 to the 12 multiplied by ax to the 0, that's just 1. And then 12 choose 1, which is 12, multiplied by 1 multiplied by ax gives us 12ax. And then for the next term, we have 12 choose 2. So we have 12, and if we go to options, then probability, we have the NCR function, so we have 12 choose 2, that's 66, so we add on 66a squared x squared, and notice ax all squared is a squared x squared, and then we add on the higher order terms. So to find the value of a, comparing the x terms, we have negative 15 over 2x, and we also have 12ax, and setting the coefficients of x equal to each other, we have 12a equals negative 15 over 2, and to find out what a is, negative 15 divided by 2 times by 12 is negative 15 over 24, which simplifies to negative 5 over 8. So a is equal to negative 5 over 8. Part B, hence find the value of k. Well, to find the value of k, we have to consider the coefficient of x squared, which is k. And we know that the coefficient of x squared is 66a squared. And we know what a is, that's negative 5 over 8. So for part B, we have 66a squared equals k. So k will equal 66 multiplied by a, which is negative 5 over 8, squared. So if we work this out, we have 66 multiplied by negative 5 over 8 squared, which is 825 over 32. We know what A is, we know what K is. We can therefore state that 1 subtract 5 over 8x to the power of 12, which is the same as 1 plus ax to the power of 12. This will equal 1 subtract 15 over 2x plus 825 over 32 x squared plus higher order terms. Using the expansion and making your method clear, part C, find an estimate for the value of 17 over 16 to the power of 12, giving an answer to 4 decimal places. Well, let's compare the 1 plus ax to the power of 12 with the 17 over 16 to the power of 12, and we know what a is, that was negative 5 over 8. We can set the 1 plus ax equal to the 17 over 16, with our value of a being negative 5 over 8. So, we have 1 subtract 5 over 8x equals 17 over 16. And what we need to do is find out what x is. To find out what x is, we would have to do 17 over 16 subtract 1, and then we would do the 1 over 16 divided by negative 5 over 8, which gets us negative 1/10, which means x is equal to negative 1 over 10. So, to find out what 17 over 16 to the power of 12 is, we would have to use the expansion in part B. So we have 1 subtract 15 over 2 multiplied by negative 1 over 10 plus 825 over 32 multiplied by negative 1 over 10 squared. So we have 1 subtract 15 over 2 multiplied by negative 1 over 10 plus 825 over 32 multiplied by negative 1 over 10 squared. As a fraction, we end up with 257 over 128. As a decimal, we end up with 2.0078125, which to 4 decimal places, we have 2.0078. Question number 7. A chimney emits smoke particles. On a particular day, the concentration of smoke particles in the air emitted by this chimney, P parts per million, is measured at various distances x meters from the chimney. Figure 2 shows a sketch of the linear relationship between log base 10 p and x that is used to model the situation. The line passes through the point 0, 3.3 and the point 6, 2.1. Part A, find a complete equation for the model in the form p equals ab to the x, where a and b are constants, gives the value of a and the value of b each to 4 significant figures. So for part A we begin with p equals ab to the x. Now we are required to take log base 10 of both sides. The reason for that is because in figure 2 we see we have a log base 10 of p, which means we have to take log base 10 of both sides. So we have log base 10 of p equals log base 10 of ab to the x, and if we split up the right hand side using the addition law of logs, we have log base 10 of p equals log base 10 of a plus log base 10 of b to the x. And now if we use the power law of logs with this log base 10 of b to the x, we have log base 10 of p equals log base 10 of a plus x multiplied by log base 10 of b. If we now find the gradient is equal to 2.1 subtract 3.3 over 6 subtract 0. And that's equal to negative 0.2. Now if we compare this equation with y equals mx plus c, we've got the y, which is log base 10 of p, we've got the m, which is log base 10 of b, we've got the x, which remains the same, and the c, which is log base 10 of a. And what we know as well is that the graph intersects the log base 10 of p axis at 3.3. So we have log base 10 of a, which will equal this 3.3. So we have log base 10 of a equals 3.3, which means a is equal to 10 to the power of 3.3. And similarly, log base 10 of b, which is effectively our m, that's equal to negative 0.2, which means b equals 10 to the negative 0.2, which means p will equal a, which is 10 to the 3.3. So 10 to the 3.3, that's 1995.26, etc. to 4 significant figures. That's 1995 multiplied by b, which is 10 to the negative 0.2. So 10 to the negative 0.2, that's 0.63095, etc. So to 4 significant figures we've got 0.6310, and then this is to the x power. So p equals 1995 multiplied by 0.6310 to the x to 4 significant figures. Part B, with reference to the model, interpret the value of AB. What we know so far is the concentration of smoke particles in the air emitted by this chimney P parts per million is measured at various distances x kilometers from the chimney. Which means for part B, the value of AB would represent the concentration in parts per million 1 kilometer from the chimney. Question number 8. Figure 3 shows a sketch of the curve C with equation y equals x cubed, subtract 14x plus 23. The line L is the tangent to C at the point A, also shown in figure 3. Given also that L has equation y equals negative 2x plus 7, for part A, show, using calculus, that the x-coordinate of A is 2. For part A, we are given that y equals x cubed subtract 14x plus 23. If we differentiate this, we can find the gradient function of the tangent. So dy over dx equals 3x squared subtract 14. So what we need to do with this 3x squared subtract 14 is set it equal to negative 2. The reason for that is because L is a tangent to C at the point A, and with that we can find out the x-coordinate of A. So we have 3x squared subtract 14 equals negative 2. If I add 14 to both sides, we end up with 3x squared equals 12, and if we divide by 3 and then square root, x equals plus minus 2. And because A is in the first quadrant, x equals 2 is our only solution. The line L cuts C again at the point B. Part B, verify that the x-coordinate of B is negative 4. We have the curve C and we have the line L. To verify that the x-coordinate of B is negative 4, what we are required to do is substitute in negative 4 into both C and L, and if we get the same y-coordinate, that means that indeed the x-coordinate of B is negative 4. So when x is negative 4, if we substitute into C, y equals negative 4 cubed subtract 14 multiplied by negative 4 plus 23. Let's work this out. We have negative 4 cubed subtract 14 multiplied by negative 4 plus 23, that's 15. And if I substitute in x equals negative 4 into L, y equals negative 2 multiplied by negative 4 plus 7, which is indeed 15. So because we've got the same x coordinate and the same y coordinate, that means the coordinates of B is negative 4, 15. And that's shown on the diagram here. The finite region R, shown shaded in figure 3, is bounded by C and L. And that's shown here. We've got the region R which is bounded by C and L. Let's begin by finding the coordinates of A. We know that the x-coordinate of A is 2, and if I substitute this into L, we have y equals negative 2 multiplied by 2 plus 7, which is 3. So the coordinate of A is 2, 3. Let's add this to the diagram. Now, to find the area of R, I need to find the area under C in between negative 4 and 2, and you will also notice we have a trapezium, and if I find the area under C between negative 4 and 2 and subtract from it the trapezium, that will leave me with the area of R. So let's find this area of the trapezium. Well, we have 1/2 multiplied by, well, we have to sum the two parallel sides. So we have a length of 15 and a length of 3. So we have 15 plus 3, and then we multiply by the height. The height is the difference between the 2 and the negative 4. That leaves this height here. So we have 2 subtract negative 4. And if we work this out, 15 plus 3 is 18, and if I multiply this by 6 and then divide by 2, the area of the trapezium you will find to equal 54. Let us now find the area under C between negative 4 and 2. We can find that out using integration. So the area under C is given by the integral of x cubed subtract 14x plus 23 with respect to x in between negative 4 and 2. So let's work out this. Well, if I integrate x cubed, I end up with x to the 4 over 4. If I integrate negative 14x, I end up with negative 7x squared. And if I integrate 23, I end up with 23x. And so we need to integrate between negative 4 and 2. So if I substitute in for my upper limit, I've got 2 to the power of 4 over 4, subtract 7 multiplied by 2 squared, plus 23 multiplied by 2. And for my lower limit, I've got negative 4 to the 4 over 4, subtract 7 multiplied by negative 4 squared, plus 23 multiplied by negative 4. So let's work this out. We have 2 to the 4 over 4, subtract 7 multiplied by 2 squared, plus 23 multiplied by 2, subtract negative 4 to the 4 over 4, subtract 7 multiplied by negative 4 squared, plus 23 multiplied by negative 4. It turns out we end up with 162. Therefore, to find the area of R, we need to do 162 subtract 54. So the area of R is 162 subtract 54, which is 108 units squared. Question number 9. P equals log base A of 16, Q equals log base A of 25, where A is a constant. Find in terms of P and or Q, for part A, log base A of 256. For part A, log base A of 256 can be rewritten as log base A of 16 squared. 16 squared is the same as 256. If we now use the power law of logs, this is the same as 2 multiplied by log base A of 16. And knowing that log base A of 16 is equal to P, we end up with 2P. Question number 10. Figure 4 shows a sketch of the circle C, the point P with x coordinate negative 1 and y coordinate k plus 8 is the centre of C, the point Q with x coordinate 3 and y coordinate k squared, subtract 2k, lies on C. K is a positive constant. The line L is a tangent to C at Q. Given that the gradient of L is negative 2, part A, show that k squared subtract 3k subtract 10 equals 0. If we know the gradient of L is negative 2, that means the gradient of the tangent is negative 2, from which we can find the gradient of the normal. That's 1/2. The negative reciprocal of negative 2 is 1/2. Now, we can find the gradient of PQ, and once we found the gradient of PQ, we can set that equal to 1/2, because PQ is the normal. In other words, PQ is the radius. So, we have k squared subtract 2k subtract k plus 8 over 3 subtract negative 1. So if we simplify this, we have k squared, then we have negative 2k subtract another k, so that's negative 3k, then we have negative 8 over 3 subtract negative 1, which is 4. And what we can do then is set this equal to the normal. So we have k squared subtract 3k subtract 8 over 4 equals 1/2. And if I multiply both sides by 4, well, 4 times a half is 2, and if I subtract that from both sides, we end up with k squared subtract 3k subtract 10 equals 0. Part B, log base A of 100. So for part B, log base A of 100 is the same as log base A of 4 times by 25. 4 times 25 is 100. So we have log base a of, now 4 can be rewritten as 16 to the power of 1/2, and we multiply this by 25. And if we use the addition law of logs, what this is the same as is log base a of 16 to the half plus log base a of 25. And if we use the power law of logs with this log base a of 16 to the 1/2, we have 1/2 multiplied by log base a of 16 plus log base a of 25. So knowing that log base a of 16 is p, we have 1/2 p, and knowing that log base a of 25 is q, we add on q, meaning log base a of 100 is equal to 1/2 p plus q. Part C, log base a of 80 multiplied by log base a of 3.2. Log base a of 80 multiplied by log base a of 3.2, that's equivalent to log base a of 16 times 5, now 16 times 5 is 80, multiplied by log base a of 16 over 5. 16 over 5 is the same as 3.2. So we have log base a of 16 multiplied by 25 to the 1/2. 25 to the 1/2 is the same as 5. And we multiply this by log base a of 16 over 25 to the 1/2. 25 to the 1/2 is the same as 5. So now if we use the addition law of logs and the subtraction law of logs, log base a of 16 multiplied by 25 to the 1/2 is the same as log base a of 16 plus log base a of 25 to the 1/2. And using the subtraction law for log base a of 16 over 25 to the 1/2, we have log base a of 16 subtract log base a of 25 to the 1/2. So log base a of 16 remains as it is, and here we can use the power law of logs, so we have 1/2 multiplied by log base a of 25, and we multiply this by, well, log base a of 16 remains as it is, and we subtract from this using the power law of logs 1/2 multiplied by log base a of 25. Log base a of 16 is equal to p, log base a of 25 is equal to q, so we end up with p plus 1/2 q multiplied by p subtract 1/2 q. So log base a of 80 times log base a of 3.2, that's equal to p plus 1/2 q multiplied by p subtract 1/2 q. Question number 10. Figure 4 shows a sketch of the circle C, the point P with x coordinate -1 and y coordinate k plus 8 is the centre of C, the point Q with x coordinate 3 and y coordinate k squared subtract 2k lies on C, k is a positive constant, the line L is a tangent to C at Q, given that the gradient of L is -2. Part A, show that k squared subtract 3k subtract 10 equals 0. The gradient of the tangent, which is the same as the gradient of L, is -2. So the gradient of the tangent is -2, which means the gradient of the normal will be the negative reciprocal of this, which is 1/2. We can now find the gradient of PQ, which is a normal. So the gradient of PQ, that's equal to k squared subtract 2k subtract k plus 8 over 3 subtract -1. And if I simplify this, we end up with k squared, then we have -2k subtract another k, so that's -3k, then we have -8, and then 3 subtract -1, that's 4. Therefore, we've got k squared subtract 3k subtract 8 over 4, which is equal to 1/2, and we can rearrange this. So we have k squared, then we have the negative 3k, and then we have negative 8 subtract 4 times by 1/2, which is negative 10, and all this is equal to 0, which means k squared subtract 3k subtract 10 equals 0. Part B, hence find an equation for C. Before we do anything else, we need to find out the value of k. And we can do this by solving this quadratic. If I factorise, I've got k plus 2 multiplied by k subtract 5 equals 0, from which we can conclude k equals negative 2 or k equals 5. Now, k equals 5 is my only solution, and that's because k is a positive constant. In other words, k is greater than 0. And with this, we can state the coordinates of P and Q. So, the x-coordinate of P is negative 1. The y-coordinate is k plus 8. And knowing that k is 5, 5 plus 8 is 13. So the y-coordinate of P is 13. And similarly for Q, the x-coordinate we know is 3. And for the y-coordinate, we have k squared subtract 2k, and knowing that k is 5. 5 squared subtract 2 times by 5 is 15. So the y-coordinate of Q is 15. We now have enough information to work out the equation of C. Let's begin by working out the radius squared. The radius squared is equal to 3 subtract negative 1 squared plus 15 subtract 13 squared. So we have 4 squared plus 2 squared, which is 20. So the radius squared is 20 squared. So for the equation of C, we have x subtract negative 1, so that's x plus 1 squared, plus y subtract 3 squared, and that's equal to 20 squared. This is the equation of C. Question number 11. The prices of 2 precious metals are being monitored. The price per gram of metal A, VA pounds, is modelled by the equation VA equals 100 plus 20 e to the 0.04 t, where t is the number of months after monitoring began. The price per gram of metal B, VB pounds, is modelled by the equation VB equals P e to the negative 0.02 t, where P is a positive constant and t is the number of months after monitoring began. Given that VB equals 2 VA when t equals 0, part A, find the value of P. When t equals 0, VA is equal to 100 plus 20 e to the 0. 20 e to the 0 is just 20, and adding this to 100, we get 120. So VA is 120 when t is 0. So therefore, knowing that VB is twice VA when t is 0, VB is equal to 2 times by 120, which is 240. So VB is 240 when t is 0. And knowing that VB equals P e to the negative 0.02 t, when t is 0, we would have P e to the 0 equals 240, which means P is equal to 240, meaning VB is given by 240 e to the negative 0.02 t. When t equals t, the rate of increase in the price per gram of metal A was equal to the rate of decrease in the price per gram of metal B. Find the value of t, giving your answer to 1 decimal place. To begin with, we are required to differentiate VA with respect to t. So differentiating 100 we get 0, and differentiating 20e to the 0.04 t, we end up with 0.8 e to the 0.04 t. which means dVA over dt is 0.8 e to the 0.04t. We now have to find the rate of decrease in the price per gram of metal B. Noticing we have a rate of decrease, dVB over dt will equal the negative differential of Vb with respect to t. So if I differentiate 240 e to the negative 0.02t, I end up with negative 4.8 e to the negative 0.02t. And because we are concerned with the rate of decrease, we multiply this by negative 1, and therefore dVB over dt will equal 4.8 e to the negative 0.02t. So, if we now set these equal to each other when t equals t, we have 0.8 e to the 0.04t equals 4.8 e to the negative 0.02t. So, if we multiply both sides by e to the 0.02t and then divide both sides by 0.8, we end up with e to the 0.06t equals 6. And if I take the natural log of both sides, 0.06t is equal to the natural log of 6, and from this we can find out what t is. So we have the natural log of 6 over 0.06, which is 29.86, etc. So to one decimal place, t is equal to 29.8. Question number 12. Figure 5 shows the plan view of the design for a swimming pool. The pool is modelled as a quarter of a circle joined to two equal-sized rectangles as shown. Given that the quarter circle has radius x meters, the rectangles each have length x meters and width y meters, the total surface area of the swimming pool is 100 meters squared. Part A, show that according to the model the perimeter p meters of the swimming pool is given by p equals 2x plus 200 over x. To begin with, we can find out the surface area. For the surface area, we've got two of these rectangles. Those have areas xy each. And then we've got this quarter circle, which have an area of pi xy over 4. And the reason we divide by 4 is because we've got a quarter of a circle. So the surface area is equal to 2xy, those are the two rectangles, plus pi xy over 4, that's a quarter circle. And we know that the total surface area of the swimming pool is 100 meters squared, which means 2xy plus pi xy over 4 equals 100. Now what we need to do is find the perimeter. And you'll notice in our show that question we have no y's, which means we would have to find out what y is first. So if I rearrange for y, you will find y to equal 400 subtract pi x squared over 8x. And now let's find out what p is, the perimeter. So we've got this x here, we've got a y here, a y here, a y here, and a y here, and for this bit we would have a quarter of a semicircle, so that would be 2 pi times the radius x over 4. So the perimeter is 2x plus 4y plus 2 pi x over 4. And knowing what y is, we have 2x plus 4 lots of 400 subtract pi x squared over 8x plus 2 pi x over 4. So let's try to simplify this. Well, we've got this 2x here. Then we've got 4 times by negative pi x squared over 8x plus 2 pi x over 4, those simplify to 0, and then we've got 4 times by 400 over 8x, which is 200 over x. So this simplifies to 2x plus 200 over x. And therefore we can rewrite this as 2x plus 200 x to the negative 1. Part B, use calculus to find the value of x for which p has a stationary value. So before we do anything else, because we are told to find the value of x for which p has a stationary value, we would have to differentiate p with respect to x. So dp over dx, that's equal to 2 plus negative 200 x to the negative 2. So we have dp over dx equals 2 subtract 200 x to the negative 2. And because we are concerned with the stationary value, we would have to set dp over dx equal to 0. So we have 2 subtract 200x to the negative 2 equals 0, and if we rearrange, x squared is equal to 100, which means x is equal to 10. Part C, prove by further calculus that this value of x gives a minimum value for p. Now, because we are concerned with the minimum value, we would have to differentiate dp over dx. In other words, we have to find the second derivative of p with respect to x. So, d squared p over dx squared, differentiating, we end up with 400x to the negative 3. And we have to verify that x equals 10 gives a minimum. So when x equals 10, d squared p over dx squared is equal to 400 multiplied by 10 to the negative 3. And you'll find that equals 0.4. And because 0.4 is greater than 0, we can therefore conclude when x equals 10, we have a minimum perimeter. Access to the pool is by side AB shown in figure 5. Given that AB must be at least 1 meter, Part D, determine according to the model whether the swimming pool with the minimum perimeter would be suitable. So access is via AB, and AB corresponds to a length of y. So what we need to do is find out what the value of y is when x is 10, because x equals 10 corresponds to the minimum perimeter. So we have y equals 400 subtract pi multiplied by 10 squared over 8 multiplied by 10. So let's work this out. We have 400 subtract pi multiplied by 10 squared over 8 multiplied by 10. And it turns out we get 1.07, etc. And because this is greater than the 1 meter that's required, this x equals 10 is suitable. Question number 13, Part A. Show that the equation sin theta multiplied by 7 sin theta subtract 4 cos theta equals 4 can be written as 3 tan squared theta subtract 4 tan theta subtract 4 equals 0. What we have to begin with is sin theta multiplied by 7 sin theta subtract 4 cos theta equals 4. Now let's expand the brackets. Sin theta multiplied by 7 sin theta, that's 7 sin squared theta. Sin theta multiplied by negative 4 cos theta, that's negative 4 sin theta cos theta, and this is equal to 4. Now if we pay attention to our show that involves terms involving tan only. So if we divide both sides by cos squared theta, we will end up with some terms involving tan. So we have 7 sin squared theta over cos squared theta, that's 7 tan squared theta. Then we've got negative 4 sin theta cos theta over cos squared theta. Now cos theta over cos squared theta, that's just 1 over cos theta. So I've got 4 sin theta over cos theta we end up with, including this negative, with negative 4 tan theta. And on the right hand side we have 4 over cos squared theta. On the left hand side we can rewrite 7 tan squared theta as 3 tan squared theta plus 4 tan squared theta, and then the negative 4 tan theta remains as it is. And on the right hand side we still have the 4 over cos squared theta. So let's simplify this even further. Well, we have 3 tan squared theta, then we subtract from this 4 tan theta, and this 4 tan squared theta we can rewrite as 4 sine squared theta over cos squared theta, and this is equal to 4 over cos squared theta. So now let's make the right hand side equal to 0, and for this we would have to subtract from both sides 4 over cos squared theta. So I have 3 tan squared theta, subtract 4 tan theta, plus 4 sine squared theta, subtract 4, all over cos squared theta, and this is equal to 0. So we have 3 tan squared theta, subtract 4 tan theta, and for this term we can factorise out a 4, and inside the bracket we would have sine squared theta subtract 1, and then we divide this by cos squared theta, and this is equal to 0. Now sine squared theta subtract 1 is negative cos squared theta, and then we have to multiply by the positive 4. So we end up with 3 tan squared theta subtract 4 tan theta subtract 4 cos squared theta, and don't forget we still divide by cos squared theta, and this is equal to 0. And noticing that cos squared theta over cos squared theta simplifies to 1, we end up with 3 tan squared theta subtract 4 tan theta subtract 4 equals 0. Part B, solve for x being in between 0 and 360 degrees. Sin x multiplied by 7 sin x subtract 4 cos x equals 4, giving it answers to 1 decimal place. Well, do you notice instead of having a theta we have an x? Therefore we can use the result we found in part A, replacing the theta with an x. So for part B we have sin x multiplied by 7 sin x subtract 4 cos x equals 4, and using the result from part A we have 3 tan squared x subtract 4 tan x subtract 4 equals 0. We can factorise this quadratic in tan. So we have tan x subtract 2 multiplied by 3 tan x plus 2, and this is equal to 0, which means tan x is equal to 2, or tan x is equal to negative 2/3. Here is the graph of y equals tan x. We've got the line y equals 2. We've got our first solution, which we can find by doing the inverse tangent of 2. That gets us with 63.4, etc. To find the next value, we add on 180 to this, leaving us with 243.4, etc. Let's think about the tan x equals negative 2/3. Here is the line y equals negative 2/3. To find our first solution, we would do the inverse tangent of negative 2/3, which is negative 33.69, etc. Here the graph goes from 0 to 360, so let's add on 180 to find this first value of 146.3, etc. To find the next value, add on another 180, we end up with 326.3, etc. Meaning the values of x are given by 63.4, that's this one here, 146.3, 243.4, 326.3, and these are given to one decimal place. Part C, hence find the smallest solution of the equation sin 4 alpha multiplied by 7 sin 4 alpha subtract 4 cos 4 alpha equals 4 in the range 720 degrees is less than alpha, which is less than 1080 degrees, giving an answer to one decimal place. Before we do anything else, we have to find out our new domain. If I multiply 720 by 4, I get 2880, and this is less than 4 alpha, which is less than 1080 multiplied by 4, which is 4320. So, to find the smallest value in this domain, I have to consider this 63.4. So I've got 4 alpha equals, well, if I do the inverse tangent of the two, I've got that 63.4, etc. And let's keep adding on 180 up until I get a value that's within this domain. Again, we need to add on 180, add on 180 again, add on another 180. So we continue this process up until we get a value in this domain. And the reason we add on 180 is because tan is periodic with 180. What you can see is 4 alpha equals 2943.4. The reason for that is this value lies within this domain, and if I divide this by 4, you will find alpha to equal 735.9 to one decimal place. Question number 14. Prove using algebra that n squared plus 5n is even for all natural numbers. Well, to begin with, when n is even, that is to say that n is equal to 2k for some positive integer k. Replacing the n with 2k, we have 2k squared plus 5 lots of 2k, and if I work this out, well, 2k all squared, that's 4k squared, and 5 times by 2k, that's 10k. Now I want to show that this result is even, so if I factorise out a 2, I have 2 multiplied by 2k squared, which gives me the 4k squared, and 2 times by 5k, which gives me the 10k. So I have 2 multiplied by an integer, which is even. So the result is true when n is even. Similarly, when n is odd, that's to say that n is equal to 2k plus 1 for some positive integer k. Replacing n with 2k plus 1, I have 2k plus 1 squared plus 5 lots of 2k plus 1. And if I expand and simplify, well, 2k plus 1 all squared would simplify to 4k squared plus 4k plus 1. And then I add on to this 10k plus 5. And if I simplify by adding the 5 and the 1, and the 4k with the 10k, I end up with 4k squared plus 14k plus 6. And if I factorise out a 2 because I want to show that this result is even, I have 2 lots of 2k squared, that gives me the 4k squared, plus 7k, 2 times by 7k gives me 14k, plus 3, 2 times by 3 gives me 6. So what I have here is 2 multiplied by an integer, which is even. We saw when n is even, we end up with the expression being even. We saw when n was odd, the expression was even, which means n squared plus 5n is always even for n belonging to a set of natural numbers.